Welcome to SIN503 Super Lab, predicting the results of an initial trial or measurements in an experiment. If you were just watching the video now, what you should have in front of you is the SIN503 skill sheet and something to write with. We're going to go through the overview together. We're then going to do some Pac-Manning. We'll answer some questions with some explanations. You'll be all set to take the quiz. Let's start at the beginning with the background information. For data, representations, and research summary passages, data from experiments are known. In order to understand the passages, you first must understand the experiments that were run. You should always be able to determine the following information about the design of an experiment. P of Pac-Man stands for procedure. What does it mean? A is the aim. What were the scientists hoping to learn or answer by completing this experiment? C is change. What variable did the scientists manipulate or change on purpose? Also known as independent variable. M, measuring. What did the scientists collect or measure in the experiment? This is the dependent variable. A, apparatus or materials. What equipment did the scientists use to complete the experiment? And last but not least, N, next. What could the scientists study or experiment next in order to gain new information? Remember with SIN503, it's an SIN scale, so we're going to be looking at experiments. Particularly when we say predict the results of the initial trial and measurement, we'll say, hey, what if we did this instead? What if we messed with this? What if we redid this? What if we reran it with this different item or with this different circumstance? What would happen? We have to use what happened in the past to predict the future. Let's get started by reading through the passage together. At this point, you want to have a pen, pencil, and highlighter in your hand. You are circling, highlighting, or underlining any words that you find tricky or confusing. Passage 3. Scientists wanted to determine the impact an object's starting height and mass would have on the size of the crater it made in play. Experiment 1. A golf ball with a mass of 45 grams was dropped from multiple heights on a clay surface. The scientists measured the diameter of the imprint created in the clay surface. The results are shown in Table 1. Experiment 2. A plastic golf ball, mass 4.5 grams, that was the same size as the golf ball used in experiment 1, was dropped from multiple heights on the clay surface. The scientists measured the diameter of the crater created in the clay surface. The results are shown in Table 2. Alright, as we take a look at this again, there's not a ton of reading in this passage. Alright, but let's go through. Is there any words that we need to circle, highlight, underline, or to do? Any words we want to do? Word. And great. Any other words outside of those two that people want to go through? All right. As we start to take a look at these words, then remember there's 3 ways that we can learn new words in science. Either defined for you in the passage, use background or context clues, or look it up. In the ACT, we want a dictionary, so we try to avoid that one on the skill sheets. So this one says the scientists measured the diameter of the imprint created in the clay surface and dropped the golf ball at the clay surface. Imprint, is it defined for us? What does it mean?
Oh, like the dent?
Yeah, essentially dent is a great synonym for it. Right, if you have a round object and you have a clay surface and you drop the round object onto the soft surface, what it will do is it will physically create a dent left over. Or what? You remove the object, you see a hole. That is called the indent. Right, that is also known as a crater. Alright, so this other word, crater, referring to the same thing. Crater. You then see 2 data tables. Alright, multiple heights drops and diameters. What you want to do in your teams at this point is you want to Pac-Man experiment 1, and then Pac-Man experiment 2. You also want to do this while you are at home. Once you have finished Pac-Manning experiment 1 and experiment 2, you want to press play. At this point, you should pause the video until you have finished both of your Pac-Man. Alright, at this point, if you are pressing play, you're ready to go through the Pac-Mans together. Alright, for the Pac-Mans, let's get started off with the first one. A golf ball with a mass of 45 grams was dropped from multiple heights onto a clay surface. The scientists measured the diameter of the imprint created in the clay surface. Results are shown in Table 1. Now, you can easily get frustrated with a Pac-Man if you feel like immediately you don't understand the procedure. Because you don't have to start at the beginning. You can start wherever you want. All right. Sometimes the easiest place to start is with the materials because those are the easiest things to just kind of pull out. All right. So let's in this case get started with the materials. Just based on the reading, what are we going to need in order to effectively run this experiment? What are some things that we would need?
Instead of golf ball, clay, surface, and ruler.
Let's see. We need a golf ball. We said clay. What else did you say?
A ruler.
A ruler. Right. Anything else that we would need for this experiment?
Flat surface.
Some sort of flat surface. Nice. Good. Anything else we would need? I'm pretty sure that's it. Okay. So now we've listed out some materials we're going to need. Maybe this helps us understand the experiment a little bit better. We know there's somehow we're involved with a golf ball. Somehow there's clay involved, a ruler involved, and a flat surface. So let's try to put some of those things together. All right, and let's not even necessarily go for the P or the A yet. All right, let's just go for change in measure. Now, change in measure, they sometimes describe for you in the passage, but there's also an easier place to sometimes figure out what they changed on purpose and what they measured. Where can you find this stuff? All right. Yeah, in the table, because the table will tell you these things, right, maybe that you couldn't necessarily find in the reading itself. All right, so what did they change on purpose? Nice. The first one, all right, your x-axis, they changed the height. And what did they measure?
The diameter of the
Nice. The diameter of the imprint. All right, the imprint size. Okay. Now let's try to make these actually just a little bit more specific. They changed the height of what? So you notice here it just says height, but it doesn't necessarily tell you height of what. What did they change the height of?
golf ball. The golf ball drop.
The golf ball. Nice. Because what it says here is a golf ball was dropped from multiple heights. So what did they drop? What did they change the height of? The height of the golf ball. All right. And now when we say the imprint size, what is the imprint in? What substance is holding the imprint for us according to the passage? The scientists measured. We can find it right in the next sentence. We use kind of a combination of what we see in the table plus in the passage. And what do we see? The imprints in what? The clay. Fantastic. All right. The diameter of the imprint created in the clay surface. Imprint size of clay. All right. Now we can start to, with all this information, put together maybe a little bit more and try to understand the experiment. Now this is a pretty simple experiment to design. We're not really doing anything complicated here. All right, they're dropping a golf ball from different heights, measuring the dent that it makes in the clay. All right, so if we take a look at this, then how would you run this experiment? How would you run an experiment like this, where you're changing the height and measuring the imprint? Thank you. Well, how would you run it? What's the procedure that you would do?
Use the golf ball
Okay, get a golf ball. What would you do with it?
and at the height of 0.2 millimeters, you drop it from there.
Nice 0.2 meters. So drop ball from 0.2 meters. And then what?
And then by every dent after it, you keep going further and further up from height.
Measure.
Measuring the diameter of the
So we measured the dent size. Then you said increase the height. How much are we?
by 0.2.
Nice. By 0.2 meters. And repeat. And how many times do we end up repeating it?
5.
Right. For a total of 5 times. We did it once and repeat it 4 more times. Fantastic. All right, take a golf ball, hold it up yay high. 0.2 meters is 20 centimeters. Pull it up and let it go. It's the clay, and you get a very little thing. All right? But what do you notice happens? The higher you drop the golf ball from, what happens to the dent? It's bigger to the point where at 1 meter, the dent is much larger. Why is that? Why is the dent bigger if you drop it from a higher height? Nice, yeah, going faster by the time I hit the ground. Gravity is causing it to accelerate. Faster, faster, faster. Boom. You're dead. All right, so what are they trying to figure out in this experiment? What is the aim of this experiment? That's perfect. To figure out the relationship or the impact of height drops on crater size. All right, so the impact of height of fall on imprint size. Excellent. All right, so how could we change this experiment a little bit? All right, if we're going to run a next on this, how can we take what we currently have and do a little bit more with it? All right, what do you think? Change the ball. Nice. What? A plastic golf ball. Boy, can he predict future experiments. Look at this. What we want to go through now is experiment 2. Look at this. All right. What do we notice about experiment 2?
They're using a plastic golf ball with the same shape.
Nice. So, procedure, same or different?
Same.
Same, with one small variation. All right, what's the difference here? Nice. So instead of dropping a golf ball, what are we dropping? A plastic golf ball. Okay. Does the aim change?
No.
Our original aim was impact of height of ball on impact size, and that looks like it should stay the same. Does the change?
Nope.
Does the measure change?
Nope.
Nope. Does the materials change?
Yes.
Yes. This is what's important in this one. We're changing the materials to what? Plastic golf ball. What's the difference between the plastic golf ball and the regular golf ball? Perfect. And that was the perfect way to word it, is that the plastic golf ball has less mass. The plastic golf ball is not smaller. The plastic golf ball is the same size. It just has less mass because it's made of plastic instead of hard, solid string wrapped around an inner core wrapped in a solid polycarbonate shell. All right? It only has less mass. It's not any smaller. Okay? Now, the interesting thing is if we take a look at this data, then what do we notice? All right, what could you learn by looking at all of this data together, both table 1 and table 2, if you see them both at the same time, like in our original passage? What do you notice then that they learned from this lab? They actually probably learned about 4 things from this experiment. What's one thing they learned? Okay, the real golf ball's imprints are bigger than the plastic golf ball's imprints. And so what can they learn from that then?
The more mass the ball is, the bigger the imprint's going to be.
Perfect. The more mass the golf ball, the larger the imprint is, because the only thing they changed in the entire experiment was mass. When you run a good experiment, you can change one thing. And you only get to change one thing. All right, you can only change one thing. What else did they learn? So if something has more mass, it makes a bigger dent. What else did they learn?
No matter what, the higher one up, the more is the
Perfect. The higher up you drop it from, the bigger the imprint is. If you can analyze those two things from this data, you can answer any question that they're about to ask. For example, if experiment 1 was completed from heights 5.2 to 6, what do you think would happen to the dents? All right, what you have to do is you have to look back at experiment 1, see what they did it actually at, see what they're kind of changing it to, and hypothesize what the change would be. So what were the original heights of experiment 1? 0.2 was the lowest, and what was the highest? 1. What are the new heights that they're proposing we switch it to? Is that higher or shorter? Higher. So what would you expect happen to the imprints? They get bigger. All right. What you want to do in your teams right now is you want to answer questions 3 through 8. All right. Answer questions 3 through 8 based on the information that we just came together and shared. When you are, if you are watching this video at home, what you want to do is you want to pause the video now. When you've answered 3 through 8, press play, and we'll go through the answers together. If you are pressing play at this point, that means you're ready to go through the answers for questions 3 through 8. All right, question 3. Experiment 2 were repeated using a bowling ball. How would you expect the new imprint diameters to compare? Hint, compare the mass of the golf ball into 1 and 2, then compare it to what we measured in the experiment. All right, so we learned from the experiments. When we looked at experiment 1 to experiment 2, we learned that the more massive the object is, the bigger the imprint. So if we repeated experiment 2 but used a bowling ball instead, look how big that mass is. So you would expect the imprints to do what? Yeah, it's actually huge in this case. If we use the bowling ball, you see some massive things. So it should be get larger. Let's take a look at the next. Question 4. The scientists repeated experiment 1, but dropped the golf balls onto water instead of clay. How would the results have changed? How come you couldn't measure?
because the water is not that surface mass is
Right. All right. The clay works so well because when you put a dent in it, the dent stays. When you put a dent in water, it just whoosh. All right. Yeah, the dent is instantaneous, and as soon as the object leaves, the dent starts to refill itself. Okay. So it should be good. Number 5. Why did the scientists choose a plastic golf ball in the second experiment? Compared to the ball from the first experiment, the second ball needed to be what? Yes, ma'am. Excellent. All right, because they were not trying to change volume, they were just trying to change mass. Because in an experiment, how many things can you change? One. You can only change one thing. So in this case, it had to have the same volume with less mass. All right, number 6. Suppose the scientists performed another study that is identical, except they used a golf ball-sized object and had a mass of 22.5. Which of the following sets of data could you predict? What do you notice about the mass of the new object? At 22.5, what do you notice about its mass?
I said it's about half of the so you would compare the diameter to half.
Perfect. It's about half of our original mass at 45 grams. So if you took all the data here, and since the mass is half, you just kind of roughly cut them in half. You get something close to like 32, 40-ish, 53-ish. This would be 68-ish, and 76, somewhere around there. Which one's really close? All right, the mass is half. Good night. Let's take a look at the next one. To show the relationship between shape of the object dropped and the impact crater size, which of the following experiments can be performed? So in this case, we again need to remember, how many things can you change in an experiment? One. And in this new experiment, what is the one thing we want to change, as listed in the question? The shape. Now we're trying to find the relationship between shape and crater size. So the only thing we can change is shape. So this is all about going back to the original and referencing to see how many things we changed. All right, experiment 2, if we repeated it, that means we need to flip back and see what actually happened in experiment 2. In experiment 2, what was the mass we used? 4.5. And what was the shape of the object? The sphere. All right, so experiment 2 was a 4.5 gram sphere. All right, if we did that with 45, did we change the mass? Yes. And then if we had a football-shaped object, did we change the shape? Yes. So that means how many things did we change? 2. But how many can we change? 1. So this can't be the case if we change too many things. Repeat experiment 2 with a 4.5 gram spherical object. Experiment 2, if we repeated it with 4.5 grams, all right, did we change the mass? No, because experiment 2 originally used 4.5 grams, which means we didn't change the mass. All right, what if we used a spherical object? No, it's a golf ball, so it's still spherical, so we didn't change that. So now how many things did we change? None, which is not actually an experiment. That's just repeating something we've already done. All right, well, what about experiment 1? Experiment 1 had 45 grams and another spherical golf ball. All right, if we had 45 grams, is that the same or different? Same, which is good. What about the shape of the object? Did we change it or keep it the same? Change it. So how many things did we change here? 1. And was it the thing we wanted to change? Yes. Which makes sense. Because you can only change one thing, and the one thing we wanted to change was the shape, and we changed the shape. Last but not least, let's take a look at question 8. Experiment 1 we repeated using a 45 gram metal golf ball size sphere. How would you expect results to change? And there's only one conclusion that we could have drawn from this whole experiment to make a prediction. What do you think? Why would it stay the same? It's a metal golf ball.
But it's the same mass as
Even though it's metal, if it's going to have the same mass and be metal, it's probably hollow. Is the only way that you could possibly get a metal ball to have the same mass as a regular golf ball. And the only thing that we learned was the relationship between mass and the relationship between height. If we did the same thing and kept the same mass, it's going to give us the same mass. All right. If you've watched this whole video and you feel like you understand all of these questions, you are ready to take the quiz. Good luck. If you didn't get one of the questions, or one of the questions is still lingering in the back of the head and confusing, you should go backwards in the video and rewatch the question that you were confused about. If you're about to take the quiz, good luck.